In this segment, we'll finish our discussion of the Code Worlds class, and we'll introduce a new design pattern, strategy. Now, when discussing the display interface, this guy, we looked briefly at the other display class, which was dump display, right here. As you can see from the code, dump display is very simple, especially by comparison with grid display. Its add displayable method just collects displayables into a linked list, and its update method produces a text dump of the simulated time and of the two-string result and location and velocity of each displayable, with one line per displayable. Now let's look at how main uses the two display classes. So going down to Code Worlds main here, it declares a display reference and then assigns that display either a new grid display result or a new dump display result. Main's first command line argument may be G or D, indicating a choice between a grid display or a dump display. And based on that argument, main refers DSB either to a new grid display or a new dump display. Now, question 1. In what other places does the main code have to change behavior based on whether DSP is referring to a grid display or a dump display? Coming back from a pause there, none, no other places. The rest of main just uses DSP as a display adding displayables and then calling update to redo the display, both methods being called polymorphically. This is classic interface inheritance. We defined an interface describing a behavior, being a display, and then we implemented it in a couple of different ways, dump display, grid display, and then we declared a reference to the interface type in the main. We made one decision as to which implementation to point the reference to, and the rest of the code then didn't need to change at all. It worked regardless of our decision. This is also an example of another gang of four classic design pattern. We might say we chose between two different strategies of how to display the simulation, each represented by a different implementation of the display interface, right? And the design pattern is called strategy for that reason. And the strategy pattern requires, first, an interface describing some important behavior in your application, like display, two or more implementations of that interface, and those are the strategies, an interface reference that you point to one of the strategies, and then code that uses that reference without knowing which strategy it refers to. Strategy is a little like template method in that we customize the behavior of code by redefining certain methods and calling them polymorphically. But in the strategy design pattern, the redefinable methods are all concentrated in an interface, and the redefined code isn't in a subclass, it's in a separate class implementing the interface. Okay, we've already discussed much of the get and init config up here and the main methods in Code Worlds. Reading and understanding the rest of the code in those methods requires no new object-oriented concepts, so please just read them both through on your own and answer a few questions below here to wrap up the discussion. Presuming you might have read a little bit by now, let's then take a question number 2. The input file example uses capital COW cow like that. But the comparison in the code is lowercase COW. Would that be okay? Does that work? And would capital all caps COW work? And after a pause, sure, it'll work because getInitConfig does a to lowercase call on the type, effectively making it case insensitive. All right, question 3 then. If I mess up the first line of that input, maybe giving a negative margin or non-positive rows or columns, does getInitConfig process the rest of the input? Does it do any other work after such an error? And what does getInitConfig return in such a case? Again, after a pause there, well, since an exception is thrown in such cases, like here for instance, then the getInitConfig won't read any more input, and it doesn't return anything. It throws an exception. But note, it will at least close the scanner because a finally block is always executed, regardless of whether there's an exception. And question 4. What is the minimum x and y of the allowed range of animal movement? And what would it take to change that? Answering the question, the 0, 0 is the the minimum range, and that's determined by the 0 parameters being passed for low x and low y in the animal range call, the new animal range call here. And you'd have to change those to new constants or to input values in order to change the lower limits. Question 5. Do the simulated entities, animals and so forth, show in their initial positions as defined by the input file? Read the code carefully. It's actually a bug, so fix this bug. Do they ever show up in their initial input configurations? Returning from what might have been a longer pause there, we do a step on each of them before the first display update call. So they never appear in their initial positions. And this could easily be fixed by moving this display update call above that loop of initial step calls. Question 6. If two entities are in the same location in the grid display, only one will be shown in the display, as we talked about in an earlier ILQ. If I wanted, say, cow1 to be put on top of cow2 so that the former shows when they are in the same spot, I can ensure this without modifying the code. What do I do to express such a preference of one entity over another? Answering the question, the last displayable in the DSPs list wins, and the DSPs list is added to in input order. So we can make cow1 preferred over cow2 by putting cow1 after cow2 in the input. So it's added at the end in this while loop. Question 7. Methods nextInt and nextDouble in scanner, here and here for instance, can throw illegal state exception. Check the docs, it's in there. But we don't catch or announce that exception. No catch, no announce in getInitConfig. Is that okay? What will happen if this exception gets thrown by those methods in getInitConfig? And answering the question, it's a subclass of runtime exception. So we don't have to announce illegal state exception. When an uncaught exception like this is thrown, the result is a runtime exception stopping the program with a stack trace.